Hey guys, welcome back. Today I finally figured out how to make perfectly looping simulation zones. I was struggling with that the last couple times, trying to figure out a way to work it with like looping noise and stuff like that. There's issues with that I'll kind of talk to as we're working on it, but we're gonna make this looping perfect kind of particle trail system. So let's just jump right in. So the cube is what will host the system. We go to GeoNodes, new system, and then essentially when we're thinking about loops, what's important is to think about the start and end frame being exactly the same. So when it comes to noise textures, we have to remember that a noise texture is not just like let's just look at it right now. So here is the general noise. And so when we take this, and if we do beforehand, if we move it through some noise or something, or I guess if we just do this right afterwards, or I guess it's actually, my bad, it's here, right? So if we have this as a noise texture, right? So we know it's going from there to there. And let's just add in a scale node here. Just do like 2 so it's big enough. Great. So we're seeing these points. Now watch. As we pull this through, it's moving kind of sporadically. So, because it's before the noise texture, right? The noise texture is right here, okay? And it's having a vector of the general position of the entire system right beforehand. And that's what's making it kind of like generate the noise field. So if you remember looking at, I guess, we did this and look at this. If we did, let's just look at this. Basically, this is what a noise texture is in terms of 2D, right? So for the noise texture, essentially, let me just increase the contrast. So for a noise texture, what we have is a 3D space across everything, and it's having different values mapped across all the different position vectors of the entire space. So if we have all of this done, right, we know that this shape of where the black is and where the white is like blobby, and it's all over the place like a noise texture. So because of that, what that means is when looking at the geometry, as we displace it inside that 3D space, we're going to have a change in the overall noise. So when we're doing a simulation and we're kind of moving the points around, like over time, let's say we're offsetting it going up a little bit, like on the Z-axis, it's not having the same exact noise each time. So even if you're going to go through and do the 4D and loop based off of the W value to have it loop perfectly for it's the same noise gradient, the reality is the noise gradient here is not the same value. So in order for things to loop perfectly, we have to have exactly the same initial starting conditions for both of them. That's kind of the main thing. I was thinking about this a lot, and I was trying to figure out how to redo it for the particle trail stuff, and I kind of just realized the easiest solution is basically just forcing it to have the same starting position every time. And so the way you do that is with a couple simulation zones, and it's a bit much more straightforward of a setup than I was doing in the past. Cool. So let's just do that. So simulation zone first, it's coming in here, coming out here, I guess, and I guess this could be coming through, right? So we run this, and it's like exploding out and going crazy. Very cool. It's too fast. And so the important thing for the general noise is for us to make sure we have here, we do like a normalize, that's going to make it be exactly 1. We do another scale, make it like 0.05 or something. Now let's see what happens. So it's kind of centering in, it's not moving far enough away. That's cool. All we got to do is do this and then just add in a general direction we want it to go. I want it to go up a little bit, so let's add in a 0.1. Maybe it's enough, maybe not. Yep. And now they're kind of moving through the noise texture. They are centralizing like in different kind of, I guess, relative mins or something inside the noise right there. If you crank the detail, it should go away. No, it's not working. So if we change the scale, let's see, I just made it a bit bigger. There we go. So you basically want to just play around with scale and detail to see what works for you. But by having that upward force right there, it's enough for it to go through. Each time the simulation zone is being calculated, it's running all these points again through the same noise texture. And so basically each time it's updating as it's going through, and it's going to be, where we go? It's going to be having a new kind of position somewhere along that line. Very cool. Okay, so then how do we do particle trails really quick? It's really easy. So simulation, connect, and let's do a join geometry. We plug it in here. And then now when we run this, we'll have particle trails so that can be really easy to turn it into curves. I've done that a million times before, so I'm sure it'll be straightforward for you guys too. I'll show it eventually, but where is the change in the workflow, I guess, is the main question, right? It's realizing that we want to have the noise texture for the particle position, but we also want to have, so I guess I'll turn this all into a node group though. Control G. Let's just call this particle noise. Okay, so let's pull this in, cuts. Okay, so the trick is we want to basically move these points first, and that's gonna make it so we can loop it. So let's do that really quick. So we're going to do a set position. We're gonna do a noise texture. Gonna crank this down probably. We're gonna plug this into here. We're gonna do a vector math. We're gonna do the minus 0.5. We're gonna go here. We're gonna do a multiply. We're gonna just do only on here. And then now what we're gonna do is across every single frame. So we're gonna do a scene time. we're going to have this go through here. We're going to do a math node, and we can divide it by a lot, like 200 or something. Let's just see for this. How is this looking? Nice. So it's moving just a little bit. I'm happy with the motion of that. It looks fine. So now we got to do the classic way of looping that motion, make it look perfectly between the two noise textures. So let's do that really quick. So it's going to be working with the W value and keeping these exactly the same. So we're going to do Shift D. We're going to do a mix node, mix. It's going to be a vector. It's going to be this guy. It's going to be this guy. It's going to be coming in here. And then we're going to be doing the same scene time. And then it's going to be doing, basically we have the total amount of frames we care about. So it's going to be over here, divide, and let's just say 80 for now. But we can do a group inputs. And let's just do this. And let's just call this frames, or like total frames. Great. So it's 80. I'll be clean. And then we're going to do a, now we know exactly this is going from 0 to 1. We can change the interpolation if we care about it, but I think it's fine. I think linear is fine for now. That goes in there. So now we know it's going from 0 to 1 over 80 frames, right? So that means at 0, it's the A value, and at B, it's that. The question is, what is this first value? So we're saying it's this divided by 200. I'm trying to make sure these noise textures loop perfectly, so let's just do clean number flow. This right here is going to be from 0 to 1. That's good. So we know it's going from 0 to 1. So that means it's coming in here. And then I think if we just add... So at 0, yeah, so right now at 0, right? If this is at 0, this is going to 0. That means the W value is 0. So if this is at 0, that then means that, so then I'm going to make this 1. So this is at 1. This is going to be at 1, and then that's going to be 1. We just do a -1 here, right? Let's just see if this works now. There we go. This works. And the reason why it's working is because we have, we're basically going between these two values. This factor is going from 0 to 1. Like this mixed factor is going from 0 to 1. This value is starting at 0 and it's ending at 0 because we're minusing a 1. So if it's a -1 plus 1 equals 0, essentially. Cool. And the motion is not too crazy. I'm happy with it. I think this looks nice. And so then if we know it's 80 frames, it's repeating every 80 frames. I guess it should not be total frames. It should be frame noise, frame count, repeats, essentially. Cool. Now that is there. And so then when we're looking at this, it's going to be doing this, moving through. And also from here, it's going to be adding in points each time. So now what we want to do is we're going to want to add in a join geometry right here of this. So then it's coming through, the points are moving through, and we're adding in new points as it's going through. If we look at this, it's having all of these extra trails, and that's making it look quite big. So we don't want a point coming in on every single frame. So we want to have a switch here. So we're going to do a switch node, and then what we want to do is a modulo, and we want the frame number. So the frames coming in, let's say on every 10 frames, we pull it in. So let's see what this looks like now. Now new points are spawning every 10 frames, as we're seeing right here. If we look at this, we're then seeing these new points coming in, and they're trailing, and they're more off. So it's looking a bit more like expected. I think this general noise is not as big as I want it to be. So let's do a value. I guess we can just go right here, and then we can add in a scale. That looks a bit better. I'm happy with that. So now we have those points coming in every 10 frames because we have this modulo right there. And maybe that's honestly too quick. So if I go to the render properties, I turn on ray tracing, and I go to this, and I turn on 60 FPS, maybe I want it coming in every half second. So that should be 30. So let's see. There we go. I think that's a bit better. Cool. Nice. So now what we want to do is we want to cut these trails to make sure that we can have them like come alive and then die. Okay. So how are we going to do that? We're going to make sure we have an age value for all of them. We've done this many times in the past. So let's do it again really quick. So it's going to be also all of this noise probably be added into a node group. So let's do that. And this is like point distribute noise. And let's just pull out one of these factors. I think it should be this scale here. Cool. Nice. Okay. So then looking at this, we want to add in the noise texture. So noise, not noise, capture store named attribute. There we go. And we're going to be doing just this one's straight up. It's be age 1. So now all of these points should have the same thing. If you look at it, they all have one age. Perfect. Now when they're coming in, we want to make sure we have a new value for them. So we're going to be adding this in, and this is going to be named attribute age 1, plugging it in there, math. We're going to add 1. Now looking at this, going through, and we're seeing every 30 seconds, a new set coming through, which is looking good. So that then means we have different values for each set of points. Great. It's not 30 seconds, it's every 30 frames. My bad about that. Okay, so this works there. So let's just duplicate all of these and let's just put it in here. Let's say age 2. It's the same thing for this. And then let's say age 2, age 2. So now we look at this at the very end. This runs through. We have an age 1 and an age 2 value. Good. Great. Now with these things, we can then, good. Now with these, what we can then is we can trim these points. So we're going to do a delete geometry and we're going to using these values. Let's just say greater than 30. Let's see how this looks. Nice. And so by deleting with greater than 30, we then have a trailing point here for cutting that. And then we can do another delete geometry. We can just add it in. Let's just do that. Boolean math. Let's just do an and. Age 1. Let's try this. Cool. I just had the math wrong for the Boolean math because I had it as attribute exists, not the greater than. So this, so the age 1 will be how high I can get. So 60 steps essentially. And then age 2 is essentially how long it can be. So it's 30. Nice. So I finally figured out where I was making mistakes. So here, let's just go over it one more time to make sure everyone kind of sees where I'm having the same issues. So it makes perfect sense for y'all. So, okay. What we're doing, we're coming in here, this is where we had the first error, is when we're pulling in this value of the frame count, we need to make sure we use a modulo to use the frame to make sure it goes from like a certain number. So if we're having like 60 frames, we want to have it go from like 0 to like 59 over and over and over again. So this is the modulo doing that. So it's taking that overall frame count with the frame. So it's like frame number and it's like mod. That's what's happening right here. So the frame number is being modded by over here, the 60. Then we're dividing it to keep it going from a 0 to 1. So as we go past that overall count down here with the overall keyframes and stuff, the overall scene time, it will keep on repeating that noise texture. So that's working correctly as we see right here, right? So it's going to be moving back and forth as we want. It's looping. It's great. Fantastic. So that's going to be one of the things thinking about the loop to making sure we time it correctly. So we know if it's a 60 frame loop here, we have the 60 frames of 120 to 180, that's just 60 frames. That works. And then we also have the modulo right here for the 20 to be pulling in a new thing every 20 frames too. So this is also working perfectly because 20 is divisible into 63 times. So that means it's going to also loop perfectly too, which is important for making sure it, is hitting things as we would want it to work. If you did 10, it would also work and stuff like that, but it has to be divisible so it hits like perfectly with the whole loop. This is the same. This is the same. And then we're deleting the geometry. And this is also kind of where another kind of divisible thing is going to matter. So this greater than is probably going to be the most important to make sure it's going to go correctly. So this one has to be less than this one to make sure that the trail length can't exceed the overall frame count. And this being 60 means it lines up perfectly with the overall 60 loop. So with all of that together, we now have the infinite trails kind of coming up like this. Great. So we have the trails. Why is this now? Let's just... I guess for some reason I turned it off. Let's just rebake it. And bake it 120 to 180. And there we go. Now it's looking good. Cool. So the last thing we want to do is we're going to want to actually add in the curve IDs. So in order to get the points to curves to not have that weird artifact, we're going to make sure we send it to curves beforehand before we are deleting the geometries. That's kind of how we're going to fix it. So I did the curve ID in the very beginning. And it's just back here where I just did the scene time plus an index by like a bunch to make sure all of it has unique IDs. So if we look at this, the curve ID is going to always be unique essentially. So that's good. So now it's basically pretty much done. So let's again do a bake node for the animation. Let's bake it out. I think we can do like 120 to 180 and it's looping. So it's looking really good. And then all we got to do is just do some spline parameters. So let's do a spline to mesh, or it's a curve to mesh, curve star. This will look nice. Pull in the scale, shade auto, set shade smooth, turn it off so it's not smooth. And then we're gonna add in some scaling. Let's do a float curve. Let's do a spline parameter. Let's do scale to be the length. That's really kind of nice. And then let's also do a math. Let's do a float curve. Let's plug this in, plug that in, make it here. And then let's actually multiply these two and let's just scale it down a little bit, like 0.1 maybe. Now it's going. I think if we just did this, maybe that's all we do. And maybe what we can do is we can have some bigger gaps between. So if we made this to be, let's try 40 here. This can stay to be 60. Let's make this 20. And we're going in here. We have those little points coming in. Nice, so this is kind of the main effect. As we can see right here, it's looping, it's happening. We have these nice particle trails. We can make it move a bit slower if we really wanted to, but I'm really happy with it. I'm happy with the effect. I think it looks good. So but let's just go over everything one more time to make sure it makes good sense. Initially having a plane of points. From those points, we're then going to be instancing multiple times depending on the frame count. Here it's every 30 frames, a new set of points will be coming in. It's being captured in a simulation zone where we have some offset with some noise. That's then going to another simulation zone right here, where we're just kind of capturing all those trails. We're then doing some clever math with the age values in order to have a decaying trail time. It's important to make sure the overall frame count is linked to the overall trail length. It's all divisible by the same number. So if we're choosing 60, you can have 30, 20, like whatever. And then we're remeshing it and rendering it out. And I hope you guys learned something, and thanks so much for watching.
Augury.